Hi everyone, I'm Dr. N.Senthil, Associate Professor, Computer Science Engineering. Great pleasure for me to welcome you all for learning this session.
In this session, topic to be covered is building cloud computing environments under Unit 1 distributed and cloud computing. At the end of Unit 1, the students will be able to describe the core features of parallel and distributed computing in cloud. At the end of this session, the students will be able to explain the building cloud computing environments. The creation of cloud computing environments encompasses both the development of applications and systems that leverage cloud computing solutions and the creation of frameworks, platforms, and infrastructures delivering cloud computing services. The cloud computing environments are the application development and infrastructure and system development. Under the application development environment, the applications that leverage cloud computing benefit from its capability to dynamically scale on demand. One class of applications that takes the biggest advantage of this feature is that of web applications. Their performance is mostly influenced by the workload generated by varying user demands. With the division of Web 2.0 technologies, the web has become a platform for developing rich and complex applications, including enterprise applications that now leverage the internet as the preferred channel for source delivery and user interaction. These applications are characterized by complex processes that are triggered by the interaction with users and developed through interaction between several tiers behind the web front end. Another class of applications that can potentially gain considerable advantage by leveraging cloud computing is represented by resource intensive applications. These can be either data intensive or compute intensive applications. In both cases, considerable amounts of resources are required to complete the execution in reasonable time frame. It is worth noticing that these large amounts of resources are not needed constantly or for a long duration. For example, the scientific applications can require huge computing capacity to perform large scale experiments once in a while. So, it is not feasible to buy the infrastructure supporting them. In this case, the cloud computing can be the solution. Resource intensive applications are not interactive and they are mostly characterized by the batch processing. Under infrastructure and system development environment, distributed computing, virtualization, service orientation, and Web 2.0 form the core technologies enabling the provisioning of cloud services from anywhere on the globe. Developing applications and systems that leverage the cloud require knowledge across all these technologies. Moreover, new challenges need to be addressed from design and development standpoints. Distributed computing is a fundamental model for cloud computing because the cloud systems are distributed systems. Besides the administrative tasks mostly connected to the accessibility of resources in the cloud, the extreme dynamism of cloud systems, where new nodes and services are provisioned on demand, constitute the major challenge of engineers and developers. Infrastructure as a service solutions provide the capabilities to add and remove resources, but it is up to those who deploy systems on this scalable infrastructure to make use of such opportunities with wisdom and effectiveness. platform as a service solutions embedded into their core offering algorithms and rules that control the provisioning process and the lease of resources. Web 2.0 technologies constitute the interface through which the cloud computing services are delivered, managed, and provisioned. Web services have become the primary access point to cloud computing systems. Everything as a service that clearly underlines the central role of service orientation. Virtualization is another element that plays a fundamental role in cloud computing. This technology is a core feature of infrastructure used by cloud providers. These are all considerations that influence the way we program applications and systems based on cloud computing technologies. Cloud computing essentially provides the mechanisms to address surges in demand by replicating the required components of the computing systems under stress. That is heavily loaded. Dynamism, scale, and volatility of such components are main elements that should guide the design of such systems. The summary of this session is we learned about various building cloud computing environments.
I hope you found this lecture is more informative. Thank you and have a nice day.